So our MCR actively participate in effortful learning, both individually and collectively. So we really are encouraged to have you guys in groups. So like I'm gonna have you check your answers together when I check homework today before I show mine. You can discuss them and ask questions. So these are just 7 students that are supposed to happen really in every math classroom, kind of every day. It's supposed to be effortful. It shouldn't be something you shouldn't be learning something today that you knew 3 years ago. That wouldn't take any effort, right? So you should be participating with effort, both individually and collectively. Okay, get out your homework. Page 335, 27 to 32. Just sketch it. Let's do some sketches. Compare your sketches with one another. Listen, there is not one exact right answer. So if yours looks a little different from the person next to you, that's okay. It doesn't mean that one of you is wrong. And I'll show you mine and we'll talk about it. Yeah, Tori, you can move over here.
You're not really going anywhere. Is it odd or even? Odd. And then the degree would be second one. Second degree. And even because it's going in the same direction. And it's positive because it's both going. What did you Neither because they're mine. So it would be even just to make it. And then it's degrees. Wait, is it the bumps or where it's yeah, it's both. Like the little minimums and maximums, you know. So it's gonna be you have 1, 2, 3 that are the highest or lowest ones. So then it would be the second degree. And the second degree looks like I think I know. So then I said what is
Alright, Janice, so I can second the number line.
me on the same. My
Yeah, I know.
one.
Yeah.
That's correct. There's no wrong answer.
Look, yesterday after school, I was talking to a student, and I felt like I should have shown you this yesterday. We did this before studying for your midterm, so this isn't your first time seeing this, but after hearing your questions, I realized, I should have just showed this to them again. So let's take a look. All even degree functions, and even means exponent, squared, fourth, or sixth. If it doesn't say negative, they are positive, and both ends go up. even degree functions, like 2, 4, 6 degrees, if it's negative, both arrows go down. Questions on even degree, positive versus negative. Okay, odd degree. If it's odd degree and it doesn't say negative, you assume it's positive. Then it has a positive slope. It starts low and ends high. If it's odd, but it says specifically it's negative, it has a negative slope. If you want to take a picture of that, or you want to just draw a few in your notebook, you go right ahead. I think it's very helpful. I wish I would have started class yesterday with it. Correct. Yeah. So even are these three. If it specifically says negative, it's one of these. So everything you're saying, other people are saying that they're just confused about odd and negative. That's I think the most confusing one. Where's odd positive? So the good news is we're still talking about this today. We're still talking about tomorrow, so you have more time. Okay. I'm gonna show you some of the sketches I did. See where I can find them. Started with 27. So it's odd. And it doesn't say negative, so I did a positive slope from arrow to arrow. Positive slope. So I kind of picture this and even draw it before I even put these like zeros down. You know, like that's going to kind of get my head in the right place. And then it gave you all these numbers. So you're just to start low, move through the numbers, or the zeros and end high. 28 says even. It didn't say negative, so we're going to assume it was positive. So you start high, end high. Ooh, I wrote a lot when I did this one. Kind of messy. I might do some erasing. So what made this one more challenging than the other two was it said maximum and minimum. So when it said a minimum, that means that there must be a valley at that x value. So it said a minimum at -1. So I drew a dashed line just so I could see -1. And then I made sure that right at that x value was my low point. And then it said maximum at 2. So I made sure that I had a hill where x is 2. On a quiz or a test, I am likely to ask you a problem like 27 and 28, but I think these maximum minimum details are kind of difficult. All right, so here's a fifth degree. Yours could look like this, or even like this. Anything like that? Yes? Correct. Never assume something's negative. Anything is positive unless there's a negative sign of the word negative. Assume things are positive. Like a natural number. Okay, and 31. And 32.
Can you show 30?
Mm-hmm. So today's assignment, you're going to find easier than this one because you're going to actually plug in points and calculate it. It's more math, but the graphing is more precise. You feel a little better about what you're drawing. You have actual points to move to. But it's more math. Okay, all right, let's do some notes. All right, this is notes chapter 5-4. This is an effort to help you understand the location principle, the definition that you wrote down. Let's not write this, it's too much. Okay, so as far as just copying this, I think a great place to start is to write this table down. How many points do we have here? 1, 2, 3, 4, 5, 6, 7, 8 points to get a really nice, precise graph. Then do a quick sketch and plot your points and draw it. I'm going to give you a lot of time for that. And then we're going to use this to talk about the location principle. Paige, do you have a question?
No, I think.
Okay, let me know. Let me know if you see something there. Yeah, that was 6.5. Write that better. So those are X's, those are Y's. You're going to plot them, connect them. Really try to copy that graph and table. And then we're going to connect this to this idea of location principle. finish, try to figure out why it says location principle in those three spots. Like, what's special about those three spots? Don't make your dots off mine, make your dots off here. What are my dots doing? Yeah. This one right here, right? Alright, so what is special in these locations that we're pointing an arrow to and calling location principle?
They're the one side touching on that exactly.
They're right in between those points are the zeros. Yes. Now, we have a graph and a table to compare here. So I can see the zeros in the graph. There's a 0 here, there's a 0 here, and there's a 0 here. Without the graph, I can locate the zeros if I know the principle. So looking at just these numbers, why is there an arrow in these three spots and not everywhere? No? That's where the y values are changing signs. And that shows movement. This shows movement from positive to negative. And if you move from positive to negative, you have to cross an axis. So here it went from positive 3 down to negative 1. So there's definitely an x-intercept. So you can see x-intercepts by just looking at numbers. If you go from positive and negative and your x's are in order, that means you cross the x-axis. So if you want to elaborate, you could say this shows crossing the x-axis. Okay, and here we went from negative 1 up to a positive 2. Well, we must have crossed the x-axis to go from the negative side to the positive side. And so we were up in the positive region this whole time. So there was no crossing of any axis here. But we go from 1 to negative 2. So it was in between these two x's that we moved through the axis. And here, negative to negative, they both stayed down low. So anytime there's a change of sign, that'll tell you a 0 without ever having a graph. Okay. Anybody have a question about the location principle? All right, try this one. Four. Yeah, go ahead. You don't need to write the table if you don't want. You don't Write your answer down. Yeah. Do you get it, Jackson? So how many x-intercepts are shown? Gabby? Three. I can look at the table on a graph. I can find three zeros, three x-intercepts. Okay. So in this table, there are three location principal examples. Who knows one of them? Gabby?
In between 4. Oh wait, -2, 4, -1, 2, -1, -2.
Between x equals -2 and x equals -1. So right here, there is a 0 in x-intercept. Valuable data. Max? Right here, we know that there's an x-intercept. Okay, someone else, where's the last one? Savannah?
Between 2 and 3 on the x-axis.
Right there. Okay, does anybody have any questions? So what you're searching for is signs changing when the x values are in order. Okay, so right now, I was gonna have us do two graphs. I think I'm gonna shorten it. Let's just make one graph in your groups right now, and then you guys can start your assignment. But you have to do this graph together. Why'd you move it?
A graph using that chart.
No, I'm gonna put a new one up.
Okay.
If you have graph paper, get it out. So Katie, the only thing you really have to write down is what.
Yes, please.
What's your homework?
Yeah, I understand it.
Alright, you are gonna make your graph of this function, x to the 4 minus 29x squared plus 100. We're gonna use the same method we used yesterday, where you were factoring. So, I know this is really low. So step 1, I want you to try to factor this in. Step 1, try to factor it in your groups. Help each other out. Factor using a quadratic method.
Quadratic is adds and multiplies.
You need to find numbers that multiply. So 100. And add.
Okay.
And then solve your factors.
Okay. So Wouldn't it be x on the outside of something? Oh, does it not?
So in your factor, it'll be x squared.
Oh, wait, that's, oh, you're right. Because the degree is x cubed 4. You have to put x squared minus 25 times x squared minus 4. And then you say equal to 0. X squared minus 25 What is it?
All right, go ahead. Yeah, but let's watch the video. How about those? And then you set those. X is 4, X is 4. See, I remember on the other one, but I don't know how to factor.
Alright, y'all, who can share with the class what the numbers are?
425.
Please let me do this one. I never answered. Wait, Kaylee. Yes, negative 25 and negative 4. I ate. Alright, so this is what was like brand new to you yesterday. Like, how do we write it if it's a fourth degree? So instead of being x minus 25 and x minus 4, it's x squared. Okay? And changing the factor from x to x squared will create that fourth degree polynomial. So this is factors. We gotta continue. You're gonna solve those factors. It's a fourth degree polynomial. You're gonna be able to find 4 zeros.
The first one that's just supposed to be number on the chart.
So I'm gonna take this little guy. I'm gonna set it equal to 0, and I'm gonna solve this equation. The other one as well. So I'm gonna solve by square rooting. If x squared is 25, then x must be plus or minus 5. So we got x equals 5, x equals negative 5. So those are our points. 5, 0, and negative 5, 0. We know 2 points on our graph. What are the other 2 points, Jackson? What are you doing? Square root. So our other 2 points are 2 and negative 2. Okay, so factoring and solving gave us 4 real zeros for this fourth degree polynomial. The most it can have is 4. Okay, actually, Paige, are you making a table yet? Yeah. Can you shorten that?
Because it's gonna be big.
Yeah, let's not do a table. Just do these 4 points with a corrected behavior. Okay, you guys, we're not gonna do it. Some of you already started table beautiful, very good. But I don't want to spend too much time on this problem. So plot these 4 points and connect them correctly. So you're practicing. How do you draw a line through these points? Yeah. Graph these points and connect them with a curved line. I'm gonna walk around and say, did you get your ends right? It's all about the ends. Are the ends gonna be pointing in the correct direction? You have enough information to get the ends right. You need to consider what is the degree and is it positive or negative? Positive. So it would start.
They're both going up and it's positive.
A lot of what I do is verbal. That's the way I'll start paying attention in this class. Is the degree even or is it odd? What is the degree? So a degree is an exponent. Is the exponent even or odd? It's an even exponent. So that means the ends are going to go the same. If it's positive and right, so both arrows are right up high. Alright, after you see that your group has done this, well, I need everyone has done their paper correctly. You're allowed to open your workbook and start your. So I'll walk around and see how far you're getting. I'll point to your arrows and say yes or no. Nice job, Victoria. Can I tell you one thing that I didn't tell you class that I really wanted? 100 is a y-intercept. I know you can I have this other picture. This is gonna go up forever, right? Something else. Oh my god. Did you hear that? Oh, one other thing that you can see is that 100 is a y-intercept. So let's really see It's just like, this is a constant. Yours is right. Yours is right. Open your workbook. Yeah, nice. Right. You have a really solid math. Did you guys hear what I said about the 100? Right. Something to be aware of. All right, great job, you guys. You don't have to factor in your homework. It's gonna be the hardest part. No, it's a lot. Don't be it's a lot of math. It's a lot of math. Can you send me a picture of it? Of the okay, from the back. Let's change from a distance. I did. Why is it moist?
It's not moist.
It's just like that. Yeah, Yes, did I not check you guys? Yes, that's 1. Did you hear I said about the number 100? So that any constant at the end of any function is a y-intercept. This is actually what I said. So I know where how high this curve goes. It goes all the way.
Yeah. We're gonna pretend.
Yeah, it's a sketch. Okay, and you know why it's okay? You didn't show the rules here. Okay, so these are gonna be more precise. You're gonna like that better. Yes, we're just plugging in for x here. It's a lot of plugging in. So if you use a calculator, calculators have a copy and paste function. You put the equation in and you copy and pull it down, and then you can just switch the x values out, and it's quick. That one. This constant plus the
Wait, so did you say you had to use that chart?
If you can hide this
yes, but you don't have to show the
I
work
got
early.
-20. But I'm gonna check it.
I'm gonna mark them so cute.
We show the work for like the.
Yeah, show the work for 2, you guys. And then you can just use a calculator. So what I mean, I'll do a -2 right here. Do it for 2 of them. But yeah, it's a lot of work. Victoria asked a good question. How do we plot -19 and the work would didn't even go down less than 4? That 19 is getting your end behavior. So you're just gonna go down here with it. Okay? This is down on the end, very low.
Do we have to show that? Like all the way down?
Okay. I am going to shorten this for you guys. Okay.
Just do 1 and 2?
That's a lot of plugging in.
Are you guys gonna remember this if we went into?
Yeah. This is a simple thing.
If you want to do 3, because you know that's what's good for you, you do 3. But I'm gonna change this just 1 through 2. Oh, it is a weekend. The quality over quantity.
The maximum and minimum is gonna be this one will be 1, this one will be 1.
May I please remind you that plugging in is the same as synthetic division?
Yes.
Maybe you like synthetic better than plugging in. So if I put the -2 on the outside, I'm going to get the same result. 1, -3, 0, 1. Who likes that better? What is that?
Okay, hold on.
Yeah, take a look. Same answer. Remainders are y values. Okay, multiple processes to get to the same solution. I can, anything. Plugging in is the same as synthetic, they call it synthetic substitution when you plug in. Just letting you know, not to overwhelm you, but to expand your understanding.